All right, guys, we are on lesson 3 of unit 7, and we're into expressions. My period one, um, my period one is was been into these things a little bit, but the rest of you probably not as much. So anyway, let's go ahead and fill out the joke, right? And all the triangles get a T, so upside down ones, and then we'll see what we end up with here, right? And then all the squares they get an R. And then the E's get a circle, or the circles get an E here. And this is kind of a cute little thing here, right? So, what's the king of the pencil box? The ruler. Anyway, let's go ahead and get into this thing here. So, the triangles, and again, all we're doing is substituting. That's what they're trying to get to. They're going to dovetail down into some variables here in a second. But this is 24 divided by 8 plus 4. So if I was to do that, I would underline that, add the 4, and I'd end up with 12. So I would. Next one, as we scroll down here, is 24 minus 8 plus 4. 24 minus 12 is certainly going to be 12. It is, yeah. When a letter stands in place of a number, it's called a variable. Variable. Now, all variables are lowercase letters, right? And it can be any letter in the alphabet. A variable represents a specific number in each expression. So in these cases, in these expressions, when we look at this, and I'm going to try and pull that up there for you a little bit. In these cases, they're giving us the value of those, and then we're going to solve them. When we're solving for a variable, an equation, it's a little bit different. So it is. All right. So you just got to keep that in the back of your mind. All right. All right. So x is 7 plus y is 3 plus z is 2. Underline 7 plus 5. Underline, and I'll write to the right is 12 and circle it. Now, the next one is zx plus y minus z. So z is 2, and I'm going to write it how they did. 2 parentheses x is 7 plus y minus 2. So now we have multiplication. That's what that means. 14 plus 3 minus 2. 17 minus 2 is 15. Now we have y squared minus z squared. Y squared is 3 squared minus z is 2 squared. So I clearly need to simplify both exponents. Remember, we have to follow the order of operations. Please excuse my dear Aunt Sally, and we would bracket those two. 3 squared is 9, 2 squared is 4, and that gives us a solution of 5. Okay? All right, next one up is kind of a mixture. They give us and this is called a coefficient. Coefficient. So coefficient in a variable. The coefficient is the number before the variable. So 7x, which means 7 times 7 plus 5, and y is 3. Interesting, huh? So we're going to go ahead and multiply both of these, 49 plus 15, and we're going to go ahead and add those. 5 and 9 is 14, carry the 1. 1, 5, 6 is 64. Okay? So let's go ahead again, and they're progressively getting harder, and we have to follow the order of operations, so we do. So the value of z is 2, so it's 2 squared, plus 9 times y is 3, minus 3 times x is 7. And I got all those values from that key up there, right? So 2 squared is 4, plus. And since these are separated with an addition sign, I can get rid of that, minus, and I can get rid of that actually. Now, in this instance, we definitely want to go left to right. So 4 plus 27 is 31 minus 21, and we end up being a solution of 10. Okay. Okay, so let's flip it over, and we're going to get into some different things here, but it's good stuff here. Good stuff. Let me make sure my camera's okay. Let me pull you down just a little bit. There you are. All right, evaluating expressions is commonly used when substituting. All right, substituting values into geometry formulas. Okay, so it says use the formula s squared, a side square, to find the area of each of the squares. So if they're squares, we know that all the sides are congruent. And I always tell people, when it's a square, there's two ways to do it. You can take a side and square it, which is 5 square, and get 25. And these are in centimeters, and we always label area in square units. That's what that means. But there's another way to look at it. It's a quadrilateral, so you could simply just say 5 times 5 and get 25 centimeters square, right? All right, so just keep that in the back of your mind. But they want us to use this formula, s square, right? So in this case, s square is 11 square. 11 square is 121, and that's still centimeters square, right? I guess I could write in here, we have s square, which is 16 square, which is 16 times 16, which you can use your calculator if you'd like, 256 centimeters square. So that means there's 256 1 by 1 by 1 centimeters. So this would be like there's 256 of those in that box. Okay. All right. Now we're going to progress to another formula here, and it's volume, and volume is capacity, and capacity means, well, how much could it hold? Well, if it's a two-dimensional figure like these, we can only go with the area. We would have to look at these two for the volume because we have that third dimension, that depth. So we do. Okay. So first up is our formula of this, right? And the formula we're going to use is area is base times height. And really it's the same as this, up here, base times height. But it's 6 times 2 7/10, right? And it's still area, right? We're still looking for the area. How much space does it cover, right? Or how many 1 by 1 by 1 boxes in there? And we end up with 16 2/10 centimeters square. And let's circle that. Next one, formula is the same, right? Area equals base times height. Some would say length times width, and I always interchange those. So I do. And then we're going to substitute. Well, the base is 8 3/10 times the height of 4. 8 3/10 times the height of 4 is 33 2/10 centimeters square, right? Again, square units because it's area. Now we're going to get down into cubic units because it is volume. So it is. So let me check that camera there. We're in good shape. Okay. So our next formula we're going to use is that formula. If I slid back up here, is this one. Volume equals length times width times height. And you'll notice I use a cursive L, so I don't think it's just a 1, right? So my expression is, right, length, right? The length is 9 times the width is 3 times the height of 14 5/10. Now, let's say I put the 3 first and the 9 second, or the 14. It doesn't matter because, you see, there's a thing called the commutative property of multiplication. It says you can multiply in any order and still get the same answer. And when we plug all